How's it going? So today we're going to be building a REST API using Go, as well as a hosted Postgres service called Zeta. We're going to also be testing our REST API using Postman. And yeah, so let's go ahead and get started. So once you've gone ahead and downloaded and installed Golang, go ahead, open up your terminal, and I believe the Go installer should automatically set up your environment variables. At least it did for me. But if it doesn't, just make sure that you've configured your Go path. So, for example, if I come over here and I type echo, wherever my $sign is, Go path, you'll see that it shows where my Go installation is. Now, it'll actually set this for you whether or not a Go folder exists. So the first time you do this, you might not actually have a folder here. If that's the case, go ahead and make one. And then once you've done that, we're going to go ahead and cd into to the Go path, like so. And then what you would do is, I already have this set up, but what you would do is you would create a source folder. You would go into it, so cd source, and then you would create a github.com folder. Go ahead and cd into that, whatever your GitHub username is. And then once you're into that, you can go ahead and create a new directory for your project. So we'll say web developer project, I don't know, an API. Yeah, that seems good enough. So we'll cd into that. So I'm just going to say cd web developer project API, and then you can open this in code. So once you do that, just go ahead and pull over your, or in my case, I just want to pull over my VS Code instance, open up 2 screens down. So here we will open our terminal. The shortcut is Control tilde. And first thing we want to do is actually initialize our project. So to do that, we will type go mod init. I don't know what just happened. Go mod init, and then whatever the name of the project is. So in our case, I'm not typing this all over again. I'm just going to paste that like that. Actually, tell you what. Let's say github.com/m6io, because that's me, and you can do whatever like you want to name yours, and then web developer project API, like so. And then it'll create a Go mod. You can open it and you can see your name of your module as well as the Go version that you're currently on. So yeah, so that's more or less all you need to do for the setup piece. Let's go ahead and create our first program. So with Go, usually like there's, I guess, it's not like a strict enforcement, but there's like opinions on how to structure your directory. For the purposes of like this tutorial, at least in the beginning of this tutorial, we're just going to put everything in like a main.go file, because it's not going to be that much code. And then towards the end, I'll probably like show you how like one of the ways that I like to distribute my code. So we'll go ahead and say, we'll create a new file. We'll call it, I'm going to start doing this in my tutorials actually, just for the sake of like the educational bit. So if you're inside of a directory, you can basically say touch, which will create a file, and we'll say main.go. So this created main.go for us. You can also like just create the file the hard way with like your mouse, but if you don't feel like, if you feel like just staying in the terminal and just doing things with the commands, this is the way to do it. So now we have our main.go. Let's go ahead and make our first program. So we'll say, first thing we got to do is declare the name of the package. So our package is called main. And then what we want to do is we'll import the FMT package. So we'll say import FMT, in quotes, FMT. And down here, we'll define our function. So we'll say func main, and inside of the function body, we will just print hello world. There we go. All right. I am not sure what VS Code is doing right now, but it is fighting for its life. Cool. Awesome. So now we'll go ahead, and FMT this isn't a package you actually need to like install. This is part of the standard Go library, and there's a lot of packages that actually come standard with Go. So to run this program, we'll come down over here into the terminal and we'll say go run. Well, actually, before we do that, we need to build this. So we'll say go build. Here we go. And you'll see it created a exe file for us. Now, if I double click this, it'll run it. Or, well, if I open it in the File Explorer and double click it, it'll run it. But to run it from the terminal, we'll just say go run main.go. And there we go. Ran that. I think we can also say, because it named it web developer, whatever, we can say go run web developer that. Oh, oh wait, I'm tripping. We don't need to say go run. We just do that. And there we go. Yeah, I'm tripping all over the place, but you get the idea. So you can either say go run, or you can just reference the exe file directly, and it'll run it. So there you go. Let's go ahead and start creating our REST API. So the first thing that we want to do is import the mux package. So what we're going to do to get that is we're going to say go get github.com/gorilla/mux. Okay. And this will add the Gorilla package to your project. And you can actually see that in your Go mod. So you'll see this got added over here. It is going to highlight it because it's not being used. Once we start using it, though, this should go away. So now that we have this, we can go ahead and import it. So let's put our FMT inside a parentheses so that we can multi-line this. And right underneath here, we'll say, you don't have to actually type this. You can import it. Like Go is smart enough to like import this directly when you use it. But this is just for the sake of practice. So we'll say github.com/gorilla/mux. There we go. Now let's go ahead and use this. So what we're going to do is we're going to define a router, which is going to be responsible for basically handling the HTTP requests that come into our server and run different logic depending on what specific route is called. So to define a router, we're going to say router, and then we're going to use the shorthand definition. So this shorthand definition is the same thing as us saying router, or sorry, var router mux.router. So instead of us doing this and then saying router equals mux.new router, instead of us doing this, we can just say that, oops, like that. So now we can define everything in one line. It's a pretty nice, oops, this is not right. It's a pretty nice way to just like kind of simplify the the variable definitions and, you know, write less lines of code. So once we define our router, we'll go ahead and define our first route handler function. So we'll say, or route handler, which will take in a route handler function. So we'll say router.handle func. And what we're going to do is we're going to define this route for the root URL path, which would just be a /. And we are going to define a anonymous function alongside of it. So if an anonymous function is basically a function that you define and run at one time. If we wanted to reuse this function, we could actually like define it underneath here, like func handle root and then whatever. But in this case, we're only going to be running this one time and it's only going to be used over here. And it doesn't, like, we're not really worried about cleanliness just at this stage. So we'll just say func, and then this is going to take in the HTTP response writer, as well as the HTTP request reader. So inside of the function body, we're going to set the content type for our response as application/JSON, which basically allows us to respond, to send back the response in JSON format. So we'll say w.header. Well, it doesn't allow us to. It just informs the whoever's making the response that this is the type, the content type of the response. So we'll say content type application/JSON. And we are getting a little bit of screaming action over here because we haven't imported HTTP. So there we go. Import this from the standard library. And then we're going to need to encode our response and send it back. But before we can do that, we actually have to define the structure for our response. So up top, we will define a type, route response. This is going to be a struct, and this is just to structure the JSON response. And it's only going to take in, for now, it's only going to take in a message field. This is going to be of type string. And we're going to annotate this field with with a JSON tag. And this basically is to be used when you're encoding or decoding to and from JSON. It just like allows whatever package is actually handling this field to know what the corresponding JSON property is. So in this case, it's going to be message, right? So this is what the actual property in the JSON is going to look like. But this is how we're going to access it in the Go program. So now, down here inside of our handle func, we're going to say JSON.new encoder. Inside here, we'll pass in our response writer, and then we'll encode the route response. Well, here what we're saying is using the route response struct, we will pass the message, hello world, like so. And I do need to import the JSON package. There we go. And we will call this, or this route handler will be called using the get request, like so. And I'm getting an error over here. Oh, it's supposed to be methods. I'm silly. Sorry. So once we have this, we can go ahead and start up our server. So this is basically defining our route handlers. So what to do based on what endpoint is accessed given what method. And we need to actually start our server and pass our router to it so that our server knows what to do with it. So we'll say log.fatal. And here, we don't need to double line this actually. And here we'll say http.listen and serve. We are going to set our HTTP port to 5000. And you can set this to whatever you want. I like 5000. And we will pass in the router. And what log.fatal is going to do, if I imported it, is it's just going to log whatever errors occur if this fails. So this is going to run. And in the event that it fails, it will end the program and log the failure. Okay? So now we can go ahead and give this a whirl and see what happens. So we'll open up our terminal again using Control tilde, and we will say go build. And then we will say go run main.go, even though I didn't actually have to run go build, but it is what it is. So now we have hello world running. It's oh my God, I cannot speak. It's asking to access whatever. So we'll say allow, cool. And then I can use the Postman software, but I figured since we're already in VS Code and I don't feel like alt tabbing every 5 seconds, we can actually just install the extension if you don't have it. So you can head to your extensions, you can install this, and in here we can just create a new HTTP request. This will be running, or we will make the request to HTTP / local host 5000. It's going to be a GET request. We hit enter, and I need to minimize my terminal. There we go. And in here you'll see message hello world. Now before we start moving on to the next part, I do need to correct an issue. Here you'll see we're having a warning that says struct field JSON message is not compatible with reflect struct tag.get. So basically bad syntax, and that's because I forgot to put this in double quotes. So now that I save that, it'll actually it'll handle this this request correctly, or sorry, the response correctly. So I need to exit the server with Control C, and then I'll run it again. And yes, I do want to allow this. Let me just minimize my terminal, go back to Postman, and in here, you know what? I'm just going to put this over on the side because it's too much for me to go back and forth like that. And in here, if I run this request again, you'll see that it actually formatted the JSON correctly because I told it that the message is equivalent to a lowercase message. So now it responded correctly. So yeah, that's, geez, I really wish I could I don't like this Postman VS Code extension. It's kind of cluttered. We'll figure it out. We'll find our flow at some point. So yeah, so now that we got that fixed, let's just add some, actually, you know what? Before we start adding some extra stuff, let's add a new package that will save us so much time, because you notice that every time you do something, you have to go and exit your server, and then you have to run it again, and yada yada yada. And we don't want to do that. That's just that's a little bit too much. What we want to use instead is a package called air. So you can head to, it's just github.com/cosmtrek/air, and what you'll do is head down to where, there you go install. So I believe I already have this installed, but I'm going to do it anyways. So we'll say go install this, and this is going to install air. And what air does is allow us to have hot reloading. So that means is every time you save your file, it'll automatically rebuild the project, so that you don't have to keep stopping and starting your server. It'll handle all that for you. And geez, this is taking forever. I'm not sure why, but while that runs, I am going to grab something else. There's a setup piece over here somewhere. Yeah, there we go. So we're going to grab the air init because we're not going to be doing a lot of customization. We just want to use the basic default settings. So now we have air installed, and what go install does compared to go get is this installs it in your actual your global Go settings. So this gives you this gives air access to more permissions. And this isn't well, I don't know if it's more permissions. Sorry, I'm in trouble with my words today. But this isn't something that we're going to use in production. This is just a development tool. So in production, you're going to run it. You're just going to build your binaries and just run them once, and as many times as you need to restart them. But that's a different story. But for development, since we're going to be saving and stopping and starting our servers over and over again, this is just a nice little convenience. So let's go ahead and run air init, and now we created a little toml file right over here. So you'll see that, actually, let me just show you how it works. So instead of having to run go run main.go and go build and all that kind of stuff, we can just come in here and we can type air, and there you go. It is now building our program, and it says hello world. We're going to allow it, and if we go back to Postman, control enter to send it again, there you go. And just so that I can show you what it looks like when you make changes, I'm going to comment this out for a second, and now it's not going to say hello world. And I'm going to come over here and say, hello, you cool person. Like, comment, and subscribe. Okay, save that. And then we come over here and we hit control enter again. It is still building. There we go. Hello, hello, you cool person. Like, comment, and subscribe. And make sure to do that. It's always helpful. Now that we got this set up, we don't have to keep opening and closing our terminal over and over again unless we have errors. But for the convenience, I am going to add some different logging, and I'm going to get rid of FMT because one less line to get rid of the FMT package. So we'll say log, and then instead of hello world, we'll say starting server, right? And I guess down here we'll say log.print, and here we'll say setting up routes. Cool. Did I spell this wrong? I did. And then I think down here we can just say log.println listening to or listening on port 5000, like so. So now when it rebuilds, you'll see that saying running, and it says starting server, setting up routes, listening on port 5000. So every time you save and you just want to confirm that everything went well, hopefully you'll see these messages in your terminal. But because we don't need our terminal, since we don't need to keep stopping and starting our program, we can just hide that, control tilde, and since we're only going to be using this file for now, we can just hide this with control B. Now let's go ahead and start setting up our routes for this project. I like to have a good idea of what my API is going to be doing throughout or before I actually start writing it. And it's like, you don't have to have that much foresight, but it's good to have like at least an idea, like a roadmap of where you're going. So we're going to have, I guess, this project is going to have, let's see, authentication, authorization, and just like full CRUD or authorized CRUD. We don't need individual handlers for authorization, but we do need them for authentication. So we'll say our first handler is going to be register. Our second one is going to be the login. So register is going to, this is going to create users. Login is going to authenticate users. So it's going to just like make sure the credentials match. And then we're going to have our project handlers. So we'll say create project. It's going to be the first one. Then we'll do update project. Okay, I don't know why my VS Code decided to do that. It's this weird thing when I scroll, it like selects multiple lines for some reason. So the next one is update project. And I know I'm not going in order of CRUD, but there's a reason I'm doing create and update. It'll make sense in a little bit. So the next one is get projects, plural. There we go. The one after that is get project. And then the last one is delete project. Cool. So how we're going to define these is actually pretty simple. I'm just going to grab this func right here. We'll say all the way up until this blue closing bracket, and we'll just hit Control X, and we'll fix this in a second. So down here, under register, we will say, let's add a space between the parentheses. We'll say in the func, and we'll say this is func register. So this is our register function. And in here, yeah, we do want application/JSON, and rather than saying all this, have you done this? Have you like comment and subscribed? We'll say hello from register. Yeah, cool. So now I'm just gonna grab this, and because I'm lazy, I'm just gonna highlight these double slashes, Control D as many times as we have functions, hit left, hit down, hit enter, paste, the whole shebang, and then we'll just, yeah, we'll have to rename these. So the short way of me doing that is, again, highlight the slashes, hit Control D as many times as I want to, and then we're going to do Shift End so that we can select this, Control C, and then I'm going to highlight func register under login, actually, like so, and Control D again until we get to the last one. Right arrow, Control backspace, Control V, and cool. I like shortcuts, and I think you should too. You probably, if you've seen my videos by now, you know I'm a fan of these shortcuts. They help speed up development, is what I like to tell myself. Who knows? Maybe I'm actually wasting my time. So last thing we want to do is, well, we already have all the different the different names of the functions in our clipboard. So I am just going to highlight the from register within the login route, hit Control D until we get down to the delete, and then right, Control backspace, and then Control V, and there we go. So now we have all of our hello froms. All right, and let's see. So we have our function oh my gosh, our handler functions all defined, or handler methods, depending on what word you want to use. Now we need to actually use them, right? So, well, we need to actually like assign them to the router. So to do that, we will say the first one is going to be handle func / register. And this is actually not going to be a GET request. It's going to be a POST request. Cool. And right next to the register, we will pass in the, we will pass it. Geez, bro. There we go. We'll pass in the register function. So you see we're getting a little bit of a screaming action because we're not actually using any of these down here. So we'll fix that real quick. Just you can click anywhere in this line and just hit Shift Alt D a few times like that. Maybe one more. And then we'll say, I'm just going to highlight all these funcs down to the delete, right, Control Shift, or Control Shift right, Control C, go back up here. I don't remember how many that was. That was 1, 2, 3, 4, 5, 6. Cool. So we just need to make sure there's 6 of these. There are 8 of these. Get rid of 1. Cool. So now we can come over here and we'll just Control D. Wait, what? Okay, now it says there's 6. Bro, I can't count today. There we go. I don't know, or no, it said there was 8 a second ago. We're tripping, my man. So now we come down here like that, and we'll say to slash that. Actually, that's not right, but we'll fix that in a second. You know what? Actually, I will do that just for funsies. And then we'll do Control Delete, Control Paste, and there we go. Now, these are not going to be our routes. We do have login, but create project, update project, get project, this is all incorrect. These are actually going to be, for the first one, since we're posting, we're going to say posting to projects. The second one is going to be updating. So we're going to say projects / ID. So it's going to take in the ID in the parameter. And this is not going to be a post request. It's going to be a put request. Put. There we go. Yeah. So the next one is the get projects. So this is going to be a, this is also going to be just projects, like the whole thing, because we're getting all of them. And it's going to be a get request. And then we're going to have get project. This is going to be projects / ID, because we're getting a specific project. This is also going to be a get request. And the last one is going to be projects / ID again, because we're deleting a specific project. And this is going to be delete. So we have register as post, login as post, create project, that's post, update project, that's put, get projects, get project or get, and then delete project is delete. So we can save that. Then we can head back to Postman. And if we hit Control Enter, it'll say 404 page not found because we don't have a route defined at the root path anymore. So we have to come up here and we have to say projects, enter, hello from get projects, because this is a get request. Now, let's say, let's actually, I'm going to like duplicate this down. Is there not a duplicate option? Maybe I have to save it. Oh, geez. We'll, okay. Web developer API. Cool. Did I literally not just create one? Okay. You know what? There. Cool. So we'll save this in here. Did I not? Bro, what is going on? Okay. We'll just say this is get all projects. Save that. And we'll just duplicate this down a few times. So there we go. This one's actually going to be get project by ID, like that. And this one is going to be projects / we'll just say 1. And if we hit enter, it's going to say hello from get project because it has an ID. The next one, we're going to duplicate this again. And we're going to say, this one is going to be update project by ID, like that. And because this is going to be a update, we're going to be using the put request. So now we hit enter, hello from update project. If I get rid of the ID, it's going to scream method not allowed because we don't have a put request defined for the projects route it's defined for the one with the ID. So if we hit enter without an ID, it's going to say page not found because it's expecting there to be something. But if we do 1, there we go, we supplied it with an ID. If we add a slash and we do some nonsense, it'll scream and say page not found because it's only expecting 1 parameter. Cool. So that's update, and this is a put request. So let's go ahead and duplicate this again, and we'll say, geez, I meant to hit rename. So we'll rename this we'll rename this to delete project by ID, like so. And this is going to be a delete request, like so. We hit enter, hello from delete project, cool. And so forth and so on. So I'm just going to speed through the rest of these. So we have our get all, get one, update one, delete one. Was there anyone else? I think that was it, right? Oh, create one, create project. Cool. You'd think I would remember. And this is going to be a post request. We hit enter, method not allowed because we're not supposed to supply this with an ID. There we go. Delete project works, cool. And we do want to add 2 more. We're going to say, we're just going to add a request. This one's going to be a post request to localhost 5000/register. And this is going to be hello from register. So we will save this. I should rename it actually to register. Yeah. We'll do auth, or we'll do user register. Yeah. And then we'll do another one. We'll call it user login. And this is going to be at the route login. Hello from login. We want to be able to also parse our IDs from the routes that have IDs in the path, such as the update project, get project, and delete project. So in our route response, we'll add a new field. We'll call it ID. It's going to be a type string, and we'll say JSON. The JSON annotation is going to be ID, and we're going to omit it if it's empty because, because there's going to be some of these routes that don't have an ID. So this is basically going to tell it that it's fine if it's null. So we'll say omit empty, save that, and then let's go ahead and update the routes and show how to parse out the ID from the routes. So we'll say an update project to parse out the route, to parse out the parameter from the route. We'll say vars, and we'll set this to mux.vars and pass in the HTTP request. And then we will define ID to, oh bro, I'm doing this on the wrong route, sorry. Let me cut this. It's still valid. We just need to do it in update like that. Let me just zoom it a little bit and hide my sidebar. There we go. So this one is going to be like that. And we'll say ID equals to vars ID, like so. So this is just reading out the ID from the variables that are in the request URL. And in our response, we will send back the ID like this. So we'll say right next to hello from update project, we'll say ID is ID. Cool. So I'm just gonna copy this down to get project and to delete project. Like, oh, that's weird. Okay, it doesn't really usually do that. So we'll just do it like this. Cool. And then we'll use them in the response like this. And there we go. So we'll save that. And then we'll head back to Postman. And just to confirm that that worked, we go to update project. We hit Control Enter, ID 1. We put a 10, ID 10. We put all this. There's the ID. And just going to copy that. Go to delete project. Just make sure that this persisted like that. Cool. And then get project by ID. We'll add that there. Cool. Awesome. So yeah, so now we're able to actually parse out the request parameters. Before we start moving on into all the fun stuff with regards to like CRUD to the database, I do want to first set up our middleware chaining. So middleware is basically stuff that runs in between the process of you, or the stage of you getting a request and acting against that request. So basically all the stuff that you want to run in the middle of this, hence the name middleware. So we're going to create a basic middleware that is just for logging purposes. So we'll call it func logging middleware. It's going to take in the next HTTP request. So basically it's going to take in whatever is supposed to happen next so that it can actually go to this after it's done running. So I'll say next http.handler, and it's going to return an http.handler. All right. Handler. And basically what this is saying is it's gonna take in the thing that it's going to be going to next. It's gonna run whatever it needs to run inside, and then it's gonna return the handler that it took in, so that it's basically saying, okay, I'm gonna do my thing, and then I'm gonna pass everything on to the next one. So take one, pass to the next guy, kind of thing. So what we're gonna do directly inside of the middleware, because it's middleware, it's just running and returning something. So we're just immediately going to return an HTTP http.handler func. So a handler function, and we're going to set this as an anonymous function. We're going to say func. It's going to take in. There we go. Wait, come on now. Okay, I thought I would get some shorthand help, but I guess not. So I'm just going to copy this because that's basically what it's taking in. And we're going to paste that there like so. All right. We're going to open up a curly brace, and inside we're actually going to run some logic. So we'll say log.printf, and in here we're going to use some string templating. I think that's what it's called. So to do that, we're going to say parentheses s. I'm going to do this 3 times. And basically what this means is we're defining a little placeholder that we will then inject some string content into. And then at the end of this, we'll add a new line like that. And the stuff that we're going to pass into here is the request. So in this case, we're going to say remote address. So that is the, so that's just going to say like what the actual address is. So remote address, hello, there we go. That was annoying. We're going to say the method, and we're going to say the URL like that. So these are going to be parsed out of the request and are going to be injected into these 3 placeholders. And then we're going to run next.serve HTTP write read. I don't know why it doubled up on the parentheses. There we go. Why is this screaming? Oh my God, it's because I'm illiterate handler. There we go. Cool. So save that. And now let's actually use it. So we're going to use a package called Alice for middleware chaining, because middleware chaining using the standard library sucks to write. Really, honestly. So we're going to say go get github.com/justinas/Alice. I love this package so much. Let's run air again so that we have our server running. Hide that. And let's actually set up Alice. So the way we do that is actually fairly simple. We're basically going to, so the way it's going to work is we're going to say alice.new, and we're going to pass in the actual middleware chain in here. In this case, we just have one, which is the logging middleware, if I could spell, like that. And then we're going to say dot, then func, and then the actual handler function. So what I'm going to do right now is I'm going to cut this, and I'm going to go to all of these like quote commas because I'm lazy. Hit Control D a bunch of times, paste that there, And then I'm going to hit Control right and then close the parentheses I just opened. And I'm going to get rid of that open parenthesis. And I'm just going to make sure to import Alice. And we are getting screamed at. Why are we getting screamed at? Cannot use. Is that right? Why can't we use it? Oh my gosh. Okay. Sorry, I forgot this. So we have to get rid of the handle func because this is basically getting run by Alice now. So we'll just say handle and that'll work. And this is really hard to read. So what I'm going to do is I'm just going to control like that. Just hit enter. That way it's easier to read. Cool. So yeah, so now if we actually run one of these, I'm going to open up my, my terminal, head to update project and hit enter. And you're going to see, it's going to say what the address is and then what the request was and then where the URL was, right? The same thing with delete, right? Same thing with get all, and then same thing with whatever that one was, get project, all right? And there you go. So now we have some middleware chaining, and we're going to put this to good use. The next step is going to require us to create a Zeta base or a Zeta database, excuse me. So you can create a free account on Zeta. You can create it with your GitHub account or whatever. It's up to you. But note that when you create your account, you'll be given a Zeta key that you need to save. It's basically your access key. And I'm not going to show you mine, but hold on to it. And we're going to be putting it in our environment variables. Actually, yeah. We're going to be using it in our environment variables. But once you get that, like once you get your account created and your Zeta access key saved, let's go ahead and create a database. So in here, I'm going to name this database. What did we say this was called? Web developer. I cannot spell. Developer. God, that took too long. Developer projects API. And we'll just call it developer projects. Cool. And we're gonna need to use the beta access to Postgres. So this, I believe, you need to set it in your account settings. So if this doesn't show up, you're gonna need to go to your account settings first and make sure that it's set up. It's pretty straightforward. Yeah. So once you have this, we're gonna go ahead and hit next, and there you go. So that's my Postgres endpoint. I'm not worried about you taking it because this is a temporary account. But yeah, so you're gonna want to like use your own, but the access key that you're gonna need, or the API key, that's the word I was looking for. It's gonna be stored in here. So I need to get to this. There we go. Cool. So once you have that copied, let's go ahead, continue, select platform. I don't care about all this. Okay. So let's head into web developer projects. And what we're going to do first is create create two tables, one for our users for authentication and authorization, and the other one for our projects. Now we're not going to do it from the UI, and the reason is there's a few nuances about like Postgres specific options. So we're going to create it using their REST endpoint and the so they have a way to do it. So we're going to head to Postman, and I am going to provide you with a Postman config that you can import, and it'll give you access to some of these endpoints that we're about to call. So if you I'm also going to give you access to I'm going to give you the environments for you to put your access key and your Postgres URL into. So, okay, so the URL is actually not going to be the same one that we just copied. So this Postgres endpoint, this is going to be used by our application, but what we're going to be using is this one, the HTTP endpoint. So we're going to need to copy this, and you're going to need to head into Postman and just like update this value. So the Postgres URL value. And I'm not going to show you what my API key is, but you're going to update it over here. Just paste it in once you get it. I already have mine set up, so I should be good to go. So once you have that, you can just hit Control S to save that, and then head to your collections. And in the collections, you'll see there's a Zeta setup that I already have for y'all. So the first one we want to create is the projects. And it's basically just got a SQL create statement. You can freestyle and do this your own way if you want, but save yourself some time. So we're just going to go ahead and hit send. And there we go. We got a code 200. So we're just going to check in the database. You'll see there is the projects table. And we need to adapt this because there's some things that need to be added for it to be compatible with Zeta, specifically the Zeta ID and stuff. So we'll go ahead and hit adapt table. And it's not going to destroy anything that we added. So we're good. There we go. So next one is the users table. So same deal. It has a little create statement. We're just going to hit enter or send. And there we go. We have our users. Same deal with this one. We're going to adapt the table. And the last thing we want to do actually is we want to head to our schema area. And you can do this in the table itself. You don't have to do this the way I'm doing it. But basically, we want to link the user table to the project table. And how we're going to do that is we're going to come down here. We're going to say add a column. And we're going to, this is the projects, right? Yeah. And we're going to add a link to table. We're going to call this table user. And we're going to link from users. And when, I guess when it's deleted, like if the user's deleted, we can just like set the user to null. You can cascade delete if you want. And what this means is if the user's deleted, it'll delete all the projects associated with the user as well. But that's a more advanced use case, and we're not even covering the deletion of users in this tutorial. So, do with it how you will, or do with that information what you will, but that's yeah. So now let's go ahead. We create that column, and this one, you can't do it from the SQL, unfortunately. Like you can't use the foreign key. Well, you can, I think it's in the doc, but it doesn't work. So this is the way I figured out how to do it. So now we have our projects and our users, so we can go ahead and get started with, creating users. So back in VS Code, and I don't think I'm going to use the Postman extension anymore because I'm trying to like zoom in on the screen because I've gotten feedback that's like folks are not able to read what's on the screen when I'm like using it the way it's legible for like this is how I write code, and like you can't read that. So this is a little bit more legible, and like the Postman is just like obnoxious, like how like big everything is, and it's hard to navigate. So I'm just going to switch back and forth to the actual app. But you can still use this. It's the same exact UX. It's just annoying for me to have it in here. So let's say, so the first thing we want to do is we want to create our environment variables. So we'll say .env. By the way, this file and this folder, they shouldn't be committed. So if you like, I haven't set up Git for this repository, but like an example is, let's say Git init. So what I would do first and foremost is I would create a git ignore. So I'd say .git ignore, because you do not want to be committing your environment variables and your build to Git, because that doesn't make any sense. So where is it? We'll just add this to git ignore, and we'll add the temporary folder to git ignore. And there you go. And then I guess we can delete this because we don't want, well, before we delete that, yeah, we'll go ahead and delete that because we don't need it. And I think that's it. Yeah, everything else we do want. So we'll just save the git ignore, close that. And then inside of your environment variables file, you want to add two environment variables. They are the Zeta PostgreSQL, and this we're going to get it from the Zeta website. The one that you just made, which I conveniently cannot find. There it is. So you head to your settings and then grab this. Now, keep in mind, you need your API key. So you're going to want to put this in the environment variable. And of course, as usual, I'm not going to show you mine, just for security reasons. And head back to your environment variables, paste that there, and then update this. Remember, like, make sure you get the carets in here, because sometimes people will only put their API key inside the caret and then they'll be like screaming why it doesn't work. Make sure the entire thing, including the carets, you replace it with your API key. And then we also want to add a, this is just for me not to have to go back and forth, but we're going to add a JSON Web Token secret because we're going to be using JSON Web Token. And you can call this whatever you want. For the sake of the memes, I'm just going to use secret because that's so secretive. So yeah, go ahead and update your API key. And once you have that done, you can close your environment variable file, and we are basically good to go ahead and get started. So first thing we want to do, we want to install 2 new packages. So we're going to say go get github.com/joho/go.env, and that's going to allow us to read from our environment variables file. And then we're going to say go get github.com/lib/pq, and this is going to allow us to use Postgres. Now that you have those, let's right above this print line starting server, let's go ahead and import in our environment variables. So we will define an error to hold the errors in the case that the go.environment.load function fails. So what this means is if you run this and it fails, error will store this error. Okay. If there's an error, meaning if error is not nil, so this means if there's an error, then log.fatalf error loading .env file. Cool. After that, let's connect to Postgres. So we'll say con string or connection string if you want, but we're going to be short. So we'll say con string is equal to OS. So import the OS package dot get environment variable. In here, we're going to pass in the name of the environment variable. So we called that Zeta Postgres URL. And then we're going to say if the length of the connection string is 0, meaning if there is no connection string, then log fatal f Zeta PostgreSQL environment variable is not set. Save that. And let's just check our logs. Yeah, I think everything's good. So then the next part is we're going to actually open a connection to our database. So we're going to say, we're going to set the DB variable as well as the error. So if we successfully connect, it's going to store it in the database variable. Otherwise, it's going to store an error in the error variable. SQL, so we need to import the standard library SQL package, .open Postgres and the connection string. Okay, so the first one is the actual the driver for the SQL driver, excuse me, and then the connection string that we successfully got, and then we're going to do some error handling. So if error is not nil, log fatal error. So just log the error. And then we're going to add a defer db.close. And this just means that defer the closing of the database connection to when the program exits. All right. So now, if we hit Control tilde and we save again, unknown driver Postgres, that's cool. And the reason it's giving us that error is because we're supposed to import Postgres. Now, because Golang requires you to use all imports, if we try to just say github.com/lib/pq, it's going to say that we're not actually using this. Wait, what? Oh, imported and not used. Sorry. So we're going to need to import it anonymously like this. And what this means is we're telling Go that we're not going to use it like explicitly, but we actually are using it because we need it in order to connect to the database using the SQL package. So we save, and now you'll see the error goes away. And it should say, there we go. And now we are connected to Postgres. Oh, and there is one more thing that we need to do. So we need to store our connection in a app level struct. And the reason we're going to do that is because we're going to have all of our functions that require the database connection and later on the JSON web token. We want them to be able to access it kind of like state. Because Golang is not object oriented, there are no classes. So you need to have state defined somewhere. And for us, we're going to do that by creating a struct called app, like that. And this is going to hold our application state. And for the sake of this tutorial, or this part of the tutorial, that is basically only going to be the DB value, and it'll be of type SQL.db. And down somewhere over here, yeah, right over here, we're going to actually set the app, or we're going to initialize an app value, and we're going to set it to the type app. So we'll say and app. So we're initializing a new struct, or we're initializing a new app using the app struct. And we're going to set DB to DB. So the DB value of the app struct to the DB that we just created up here. If it helps you to say something like database just for your own sake, like if it helps you distinguish it better that way, that's fine too. But I just want to do it this way to stay consistent. Now it is going to scream at us because it's declared not used. So I'm just going to comment this out for now, but we're going to use it in a second. Let's go ahead and create our user registration route. So the first thing we're going to want to import or get is the bcrypt library. So we'll say we'll say go get golang.org/x/crypto, not that kind of crypto, bcrypt. And we're going to be using this to encrypt the user passwords, or to hash the user passwords, so that way you're not storing them in plain text in the database. So once you have that imported, or once you have that getted, we're not going to import it directly from here anymore. We're just going to use VS Code tooling. But before we start using it, let's go ahead and update our structs, because we're going to need one that represents our user credentials. So we'll call it type credentials, and this is a struct. This struct is going to be made up of two fields. The first one is going to be username, and the second one is going to be password. Both of these are going to be type string, and for their JSON annotation, they're going to be, we'll say JSON, username, lowercase, and we're going to omit it if it's empty. All right. So that's that one. And then we'll just copy this down, and we'll just change this to password, like so. Save that. And then we're also going to add so this route response, this is for sending back a message. But in our case, we want to send a user response. So we're just going to duplicate this up by doing Alt-Shift-Up. And we're going to rename this to user response. In here, we're going to return the Zeta ID. Now, the Zeta ID, this is the ID that's auto-generated by the Zeta database. This is going to be, the JSON annotation is going to be lowercase Zeta _ID. And the other property is going to be the username. So we're going to return the username in the user response. And for this one, let's get rid of omit empty, and we'll change this to username lowercase, like so. Now we also want to define, an error response struct. And this is going to be a struct that contains the error that's returned in the case that there is an error returned. And this is just so that we can format our errors using JSON instead of returning them as plain text, because it's going to help clients like a potential UI to parse the JSON and manage it and use it correctly. So we'll say error response, and this is simply going to take in a message. So we'll just copy the message over, and we will paste it there like so. And I think that's it for our structs. So now let's go ahead and create modify our route handler. So inside of our register handler, let's first change this comment to say register function to handle user registration. And the reason I'm doing this is because Golang, it's self-documenting. So Godoc is like basically like Golang's automatic documentation. So if you hover over this, you'll see register function handle user registration. That's derived from the comment right above the declaration of the function. So it's a good way to just keep your code legible and easy to understand without having to go to the function directly. So what we're going to do in the registration route handler, first thing we want to do is we want to define our creds as type credentials, and we want to decode them from the request body. So we'll say error JSON, error JSON.new decoder, and we're gonna decode the request body into the credentials struct that we defined up here. So we're going to say and creds like that. So what this means is read from the body and then decode it and place the result inside of this variable right here. All right. Now we want to handle this error. So we'll say if error does not equal nil, then we are going to need to send back a response. So we'll say w.header. I'm just gonna actually grab this from here. So we'll paste that there, all right? And then we're gonna write the header. So we'll say w.write header, and we're gonna add a status code. So in this case, it's gonna be http.status bad request, all right? And status bad request is a 400. So means no, not good. And then we want to, right here, just grab this line. And instead of encoding the error, the route response, we're going to encode an error response like that. And the message is going to be invalid request payload. And in order to exit this function, right underneath it, we will say return. And this just means don't complete the execution of the handler or exit here. All right. Now, let's go ahead and try this out. So if we go back to Postman, and I did supply you with or I will supply you, excuse me, with a Postman configuration that you can import. If we head into the body and we say, I don't know, like we have a username and password. So we send this and we get as 200, hello from register, because everything passed. But let's say we don't provide a username. It still works. And that's because we don't have any input validation. But let's say that we added like some incorrect JSON, right? And then we hit enter, invalid request payload. And that's basically the first check to make sure that the JSON is actually formatted correctly and can be understood. So another example is if we do something like that, I wonder if null will do anything. Oh, that will work. Okay, that's fine. Oh, it'll work because I think omit empty worked, but I wonder. Yeah, so this is a number. So so omit empty, which we said that you can provide a basically like an incomplete request body, but because we use a different type, we use a number over here, that made it invalid. So that's good. Now, before we move on, this right here, we're going to be repeating this over and over and over again. Every single time we have an error, we want to handle the error and we want to return it. The problem is, well, this is 3 lines of code that we got to be repeating over and over again. And I don't feel like doing that. So let's define a function to handle that for us. So we'll say func respond with error. And this is going to take in the response writer as well as the HTTP request. So we'll say that. Actually, no, it's not going to take in the response writer. What am I saying? It's going to take in the response writer and the code because we're passing in the status code. This is just going to be an integer. And then it's going to take in the response message, which is just going to be a string like that. Cool. Now, let's just go ahead and copy. We'll copy those and we'll paste them there. But this is going to stay the same. We're always going to return it as JSON. But this, Well, this needs to take in the code that we're passing into the function. And then in the encode area, we want to pass the message in over here. So we'll just say message. There we go. So now, rather than doing these three lines of code over and over again, we can just say respond with error, and then we can pass in the writer. We can say HTTP status bad request, so like that, I think. And then we can pass in the message, which in this case would be invalid request payload, like so. We can get rid of these 3 lines, and now we can use this respond with error everywhere we want as we move forward. And we're going to use it, I think, 2 or 3 more times in this function alone. So let's go ahead and do that. So assuming that the JSON body is fine, then the next thing we want to do is we want to hash the password that was provided in the input. So we'll say hashed password and the error. And we're going to set these to bcrypt dot generate from password. And this is assuming that you imported or that you got bcrypt, you installed the bcrypt package. I'm just going to say installed from now on because that makes sense. And in here, we're going to set this to a slice of bytes. That sounds funny when you say it out loud. So this just means like a dynamically sized array. That's what a slice is in Go. And it's going to be of type byte. So the array elements are going to be bytes. And these are going to be generated from the creds.password. And we're going to pass in the bcrypt cost. So then we'll just use the default cost. So this is just an integer. In this case, it's 10. You can write in an integer, or you can just use like whatever they have. So there's max cost. I don't know what max cost is. The maximum allowable cost. Okay, that makes sense. So default cost, we'll just use that. And why is this giving me an error? This is giving me an error because I spelled cred over here, but I should have spelled it creds from the beginning. So we'll just change that to be creds. There we go. Cool. So assuming if there was an issue with the hashing of the password, let's go ahead and return an error. So I'm just going to grab these 4 lines over here. I'm going to paste them down there. And instead of saying bad request, because the request is not bad, right? This is an error on our part. We'll say status internal server error. And in the message, we will say error hashing password. Now, obviously, we don't want to be returning this error to the users, but this is just for our own debugging purposes. You should change this later on to just be like internal server error or something like that. But this is just for the sake of like, getting through the tutorial and getting a good understanding of how error handling works. So next thing we want to do is we want to, assuming that the password hashing worked, we want to define a Zeta ID, which is going to be of type string, and this is going to hold the Zeta ID that is created by the database at the successful creation of the user. So we'll say error equals. Now this is where we have to access this thing up here. So we're going to need to access the app state because we're going to want to use the database connection. So we'll uncomment this line, and then down in the register function, to make this function use the app state, we need to make it a method of the app struct. And to do that, we add these parentheses up top next to the func declaration, and we'll say app star struct app. So this is the type. And now in here, we can access the app struct. And we'll say app.db. So now we can access the DB connection .query row. So we're going to query, or we're going to send an SQL query. And in here, we'll say insert into, because users is a protected keyword in Postgres, we have to put it in quotes. And because quotes are not things that you can put inside quotes, we're going to have to use escapes. So these 2 are just to tell the language, hey, don't worry, this is not the end of this statement. If I were to get rid of this, it would get real funky real fast, right? So we want to use the escapes when we have double quotes inside of double quotes. So we'll say users, and yeah, I know you can come in here and you can use backticks instead, and you don't have to be like really annoying about it, and you can be fancy and all that good stuff. But I don't know. I don't feel like doing that. I just do it this way because it's also like explicit for me, and it's a repeatable pattern, and it's just preference. Do it however it makes sense to you. So we're going to insert into the users table the username and the password, and we're going to get those values from these placeholders. So we'll say $. Where's the $? There it is. $1 and $2, like that. And we're going to returning, there we go, zeta underscore ID. So zeta underscore ID should get generated at the successful execution of this SQL statement. So insert into, did I spell everything right? Yeah, I think I did. Now we want to actually say what we're passing in to these placeholders. And those are going to be the creds.username and the, no, don't pass in the password. We're going to say string hashed password. So string, this is going to require us to import the string package, and it should have already, maybe not. It's from the strings package, I believe. And this is just going to convert the byte, the slice of bytes to a string, so that we can save it in the database. And it's going to be hashed. So we're not saving things in plain text, and we're going to scan. So scan is just like we're basically just like taking back the columns, and we're plugging them into the we're plugging whatever things were returned into the variable that we defined, which in this case would be the zeta ID. So we're going to scan them into zeta ID like that. So now let's just catch the error. So we'll copy these 4 lines and we'll paste them there, and we'll say server internal error. That's cool. And then we'll say error creating user, and then we'll save. So we do have an error somewhere, and I think it's because, yeah, so we need to actually use this app here. So see how it's saying undefined register? That's because we said that, because of how we defined register, we said that register is a method of the abstract. So to actually use this correctly, you have to say app.register, and the error goes away. So the last thing we want to do is in this, we don't want to say hello from register on the response. Rather, we want to say, instead of route response, we want to use the user response that we defined above. And in here, we're going to say zeta ID is equal to the zeta ID that we scanned from the successful execution of the SQL query. And we're going to say the username is, well, I mean, the username was created. Like, we don't have to return the username from the database because, like, we sent the username there. So we can just use the one that we used in the inputs. So we'll say creds.username, save that, head to Postman, and let's go ahead and try this. So we'll say enter. It's going to have an error because we used the wrong type, I think. There we go. So let's say just password, error creating user. And the error is because we didn't include the username. So we need to include the username. Hit enter. Error creating user again. Oh, it's this. So we'll say values. I literally just did it again as I noticed it. So now that we have it saved, hit this again. Okay, it's probably rebuilding. I have a slow computer. And there we go. So there's our Zeta ID for our new user, and there's the username. And just to quality check this, we'll go to the database, head to the users, and there you go. There's my first user. Let's try it again. So we'll say my first user. We'll hit enter. There's going to be an error, and that's because we have the username set to be unique. So we can't create more than one of the same person. So we'll say my second user, hit enter, and there you go. There's a second user in the database. All right, let's go ahead and implement the login route. So I'm going to minimize all of our functions by hitting Control-K, Control-0, and we're going to head into main real quick. And let's first, we're going to make login a method of the abstract as well. So we'll just go ahead and save that like so. And let's head down to login now. So inside of the login function, well, actually before we go inside, let's first make this a method of the of the abstract. There we go. So now we have access to whatever we need from the abstract, such as the database connection. So first thing we want to do is let's go ahead and actually we're going to copy a lot of stuff from register. So we're going to copy out the CRUDs piece. As a matter of fact, we're going to copy basically, yeah, we're going to copy this out, and let's head down here, paste this. So we're going to first define the credentials as they come in from the body. We're going to respond with error if there's an issue with the request, and then down here we're going to initialize a variable called stored creds, and this is essentially the credentials that are in the database as well as the Zeta ID. So var Zeta ID, and this is going to be a string. So underneath this, we're going to make a query to the oh my gosh, geez, that was a tragic stutter, to the database. So we'll say error equals app.db.query row, and in here we're going to select the Zeta ID, the username, the password. Did I spell that right? Yeah. From, and because I'm lazy, I'm just going to copy this because I don't feel like typing escapes right now. We'll paste that there. And then where username equals $1. All right, because that's going to be the first placeholder. And we're going to pass the creds.username to that placeholder. And we're going to scan the results to Zeta ID and to the stored credentials, the username of the stored credentials, and the where is it? And stored creds.password. Cool. So Zeta ID will go here, username will go here, and then password will go here. Cool. So if there's an error, let's we're actually going to copy this, paste that there. So if there's an error, we first want to check if the error is due to the fact that there are no SQL rows, meaning that the thing does not exist. So we're going to actually copy this, and inside of here, we're going to paste it again. But this time, rather than if error equals if error does not equal nil, we'll say if error equals SQL.error no rows, meaning thing not found, right? And then the status code for this will be status unauthorized, like that. And we'll say user not found. And then in here, we'll say status internal server error. Cool. And actually, we're not going to put, so I should explain this. So we're saying status unauthorized because, so this is more of an error handling for us. I should actually say invalid username or password here, because you're not technically supposed to surface the fact that the user is not found when you, well, I don't know if that's true. That's what I understood. Like when like the first time I did this years ago, and I just kind of like lived with it since then, but I don't implement user authentication myself if I can avoid it, because, you know, you always rather use a third-party service that's more stable than yours and more secure than whatever you could come up with. But yeah, I mean, in this case, you're basically saying like if the user not found, then just say invalid username and password. Cool. So then we'll come down here. So this is assuming that the username was found, right? Now, if the username was found, then we want to compare the password that the user had that had come in through the request with the hash password that's in the database. So we'll say error equals bcrypt compare hash and password, and we will pass in. Sorry, I'm looking for the slice character. So a square brackets byte, so a slice of bytes, and in here we're going to pass in the stored creds.password. So this is the password that we got back from the database, which will be the hash, and then the password itself is going to be. I'm just going to copy this because it is going to be an array of bytes, but this is going to be from the CRUDs that were passed in the request. So we're going to pass the hashed password and compare it to the password that came in from the request. If there's an error, so I'm going to grab this and I'm going to paste it here. So if there's an error, then we want to respond with unauthorized, like this. And we'll say, I don't want to say invalid password because, again, I think, I don't know. I mean, I've seen it done both ways, I think. But for the sake of safety and for the sake of me not getting, like, me not getting sued for giving potentially liable information, yeah, we'll just play it on the safe side and we'll say invalid username or password. So yeah. So now, if this succeeds, then we want to actually generate a token. So this is where we need to create a custom function to generate the token. And the reason we're creating a function is because we're actually going to use this in two places. So I'm just going to write the code for it right now. So we'll say what we're going to be trying to get is a token that's in string format and an error, and we're going to the function is going to be called generate token, and we're about to define it up top. And in generate token, we're going to take in the username as well as the Zeta ID. So now let's go ahead and create this function. So let's see, where should we do this? We'll do it above the register, just for now. And like eventually we can probably move this to like a utils or some like dedicated file. So in here, we'll say func generate token. It's going to take in username and Zeta ID. And both of these are going to be of type string. So this is like shorthand. This is instead of me having to do this. Because these are both of type string, I can just do this. All right. And it's going to return a string and an error. Notice how I said and. All right. So first thing we're going to do, expiration time. Expiration time. You know, I just realized we probably didn't even import, we probably didn't download the JSON Web Token package yet. So let's go ahead and install that or download that real quick. So we'll say go get, and it's github.com/golang jwt v5. Go ahead and pause and type this in. Cool. So once you get that, hit the terminal again. And now we can set our expiration time to time.now. There we go. .now. And we're going to add, and this, like, you can do it however you want. So this is the expiration time for the token. You can do like 5 times time.minutes if you're crazy and you and you want this thing to expire in 5 minutes. No, sorry, not minutes, minute. There we go. Or you can do like hour if you want to be like nice about it. You can just say like 1 hour. Now we want to go ahead and create a JSON Web Token claim. So we'll say claims equals, and actually before we do this, we need to actually create the claim struct. So the claim struct is just going to take in the basic JSON Web Token claim, and we'll do this. I guess since it's related to credentials, maybe we'll do it like underneath between the user response and the credentials. So we'll say type claims struct. I cannot spell struct, and this is going to have a username field. Which is going to be string, and I'm just going to grab this, except it's not going to be empty. There's no chance of it being empty. We always want to have a username in here. And as a matter of fact, I'm going to grab this from the user response, and paste it underneath it because we need the Zeta ID to be stored in here. And the last thing we want to add is the registered claim. So we'll say jwt.registered claims. All right, perfect. And I think this did import. Let's just make sure. Yeah, there it is. Okay, cool. So now let's go ahead and use the struct. Actually, tell you what, we're actually, before we go down here and before I forget, we're gonna add the token to the user response, because from now on, whenever the user logs in or registers, we want to return the token. So that way, like assuming it's successful, that way they can like get to using the application immediately. All right, so the claims is going to be set to and claims. All right, And this is going to contain the username, which is going to be set to username, which was passed in. Whoops. And then we're also going to take in the Zeta ID. And this is going to be set to the, you guessed it, the Zeta ID. And lastly, we're going to register the claims, or we're going to pass in the registered claims. So we'll say it like that. And we'll say this is going to be of type, or using the struct JWT registered claims, and expires at jwt.new numeric date expiration time. Cool. So now we have a new JWT JSON Web Token claim, which is just a standard format for JSON Web Tokens and what they contain. So we'll say token equals jwt.new with claims, and we'll use the what's it called, the H256 signing method, and I don't know why it keeps adding more brackets. Sorry, like that, as well as the claims, like so, and then we will sign the token string, the token. So we'll say token string error. So if it succeeds, it'll store into token string, and if it fails, it'll store an error. So say token dot signed signed with a D string app dot JWT key. Oh wait, I didn't define this yet. Okay, so what we need to do is we want to store our we want to use the secret that we defined earlier in our environment variable. We want to store that in our app state, and then we want to use it to sign our key, right? Because the secret is basically what you're using to, like, think of it like, well, I mean, yeah, it's a key, right? So it's what's used for the encryption and decryption. So what we'll do is inside the abstract, we'll say JSON Web Token key, and this is just going to be of type slice of bytes like that, or byte slice. It's a really funky thing to say out loud, to be honest with you. And because we're going to be using it because we're going to be using the app state, we need to make the generate token function a function of the app state. So we'll say app like what we were doing before, and now we have access to the JSON Web Token key, which, if you forgot, was stored in our environment variable. And if you forgot about it, just go back and add it. That should be earlier in the video. So if there's an issue with signing the token, we'll say if error does not equal nil. I don't know why I'm all the way down here. If error does not equal nil, then return a blank string. So this means that if there's an error, return an empty string and the error. Otherwise, return the token string and nil, because we have to return the error. So in this case, we're setting the error to nil. So we save that, and now we can actually use generate token. So we'll head down to the login. There we go. And we can actually access this by just saying app.generateToken, because this is a part of the, this is a method of the abstract. So that's how we access it. And let's just copy this error handling. And basically what we're going to say is if there's like an issue with generating the token, so if error does not equal nil, then respond with error. We'll say status internal server error. And we'll just say error generating token. And then we'll return. And if there is no error, then we will set a response type to application/JSON. And then rather than route response, we'll say user response. Actually, I think we have a user response up here. So I'm going to grab this one. I'm going to come down here and paste that there. And we'll say Zeta ID, username. And lastly, because we updated our user response to include token, we'll say token is token string, like so. So we'll save that. And now if we head over to Postman, let's go ahead and open the user login request, and let's type in a wrong username. So we hit that, says invalid username or password, right? Because that user doesn't exist. So we'll correct it to my first user. We'll hit enter, and you'll see we got the Zeta ID, username my first user, and we got a type token. I also have a script in here that will automatically set the environment's token to whatever the response is for the login and for the register. So you don't have to deal with like copy and pasting this every time you want to do an authorized request later on. So if I hit enter again, I'm pretty sure like this slightly changes towards the end. Yeah. So now if I type in a wrong password, there you go, invalid username or password. Cool. So that's that. Now let's also update the registration with the same little bit down here. So we'll say token string, we'll grab this. Well, to be honest with you, I'm wondering, I think we can grab all of this actually. Yeah, so we'll grab all of this and let's head up to the registration or the register route. And we're going to replace these last two lines with this because now we want to actually return a token when we register. So now if we head back to Postman and we try to register a user, my second user already exists, so we'll have an issue. But if we say my, I'm getting creative now, my third user, you'll see that this one also returns a token. And there you go. I realized that, I don't know how this worked, but somehow it did. But I realized that I didn't actually import the JSON Web Token secret from the environment variables. So like I'm honestly kind of struggling to understand how that even worked since we don't even have the JWT. But like we're literally not even adding it here, which is kind of funky, but probably worth debugging at some point. But let's go ahead and take care of that now. So we'll say JWT key, and we'll set that to a slice of bytes. It's really hard to like, this language is not easy to like talk and type at the same time because everything is kind of backwards. It's like, if I was Yoda, it would probably make more sense. So JWT secret, like that. And now what we'll do is we'll say if the length of JWT key is 0, then log dot fatal f is JWT underscore secret environment variable is not set. There we go. So now we have our JSON Web Token key. And there is, I guess we can go ahead and set up our JWT middleware real quick because for the rest of the use cases, we're actually going to need to first parse out the JWT prior to allowing a specific request to go through. Because we want to make sure that the user is who they say they are and that they're allowed to do the things that they're trying to do. So let's go ahead and add that middleware. So we'll say underneath the logging middleware, we'll just say func, and we will need access to the key. So we'll say app, struct app, like that. We'll say JWT middleware, okay, next, and HTTP dot handler. So it's going to take in a handler and it's going to return a Jude. I don't know why I cannot type today. Okay, there we go. Cool. Now this is going to be a yeah, this is going to be a big one. So in here, we're going to return. Tell you what, I'm going to like grab this because I am so tired of typing the same. This is the problem with like writing Go's. It's like a lot of typing. So we'll say this, and then in here, rather than just printing out whatever, we'll actually need to grab the auth header. So we'll say auth header, because the JSON Web Token gets stored in the authorization header. We're going to need to grab it from the request header dot get, and then this is going to be authorization. Hopefully I spelled that right the first time. And if the auth header is an empty string, meaning is not there, then we're going to respond with error. So I need a copy pasta this from somewhere because I don't want to keep typing this. We'll just grab it from register somewhere. Come on. Yeah, this works. Cool. So we'll head back to the JWT middleware and we'll say if the auth header is, dude, why am I hitting the wrong button? Is an empty string, then we will return or we'll respond with error, and the error is actually going to be status unauthorized because you don't have a header, and we're going to say no token provided. No token provided. Cool. So let's go ahead and not try this because we really can't. This will all make sense in a second once we get to the next route. So after this, we'll say token string. So we're going to need to take the token out of the header. So we'll say strings dot trim prefix. The standard for writing JWT tokens or JSON Web Tokens is it's bearer plus and then the actual token. So in this case, we want to trim the bearer plus out. So we'll say auth header, and we're going to trim out bearer space. Okay, and then we're going to create a claims. Claims object. So we'll say that, and then we'll say and claims. We'll just make it empty to start. And then we'll say token error. Did I already use the word token here? No, I'm good. Token error, set this to JWT dot parse with claims. So we need to actually parse out the JSON Web Token because we need to like actually figure out who this is, right? So we'll say token string, and then claims, and we're going to pass in a function in which we'll take the token, and this is going to be an optional one. So we'll say star means optional. So star JWT token, or not optional, but like possibly undefined. Yeah, that's right. And we will return an interface and an error like that. Okay. And let's open up the function body, and in here we will just return the app.jwt and nil. So this is basically going to set the token. It's going to parse out the actual information that's inside of the token, and it'll, like this function that's inside, it'll return the JWT key, and it'll be used to actually parse out whatever information is inside of the token that's passed in here. So that includes the username, the Zeta ID for the user, which is the database ID for the user, as well as the expiration date. So once we do that, we'll say if there's an error, and this will usually happen if it's like a bad token or if it wasn't signed with the right secret or whatever. So we'll say if there's an error, the first thing we're going to do is check if the error is that the JWT error signature invalid. So if it's like just a bad token, all right, we're going to respond with error. So I'm just going to grab these, paste that there, and the error is going to be status unauthorized, and we're going to say invalid token signature like that, and we're going to return. Otherwise, we're going to respond with an error, HTTP status bad request, right? Oh, bad status bad request. There we go. And we're going to say just invalid token, right? Because it's still, the error is still that it's an invalid token, but we don't know exactly what it is. So we'll say invalid token. All right. And then assuming that this, that the error is not nil, the next thing we're going to do is we're going to check if the token was valid. So we'll say if token dot valid. Okay. And this is basically like, this means that like, this is an error if there's an error parsing the token, but this is if the token was parsed and if it was determined to not be valid, right? So if it was like expired, for example, then we will respond with error, status unauthorized, and we'll say invalid token like that. Paste that there. And if the token is valid, then we're going to create a context with the claims, and we're basically just going to call the next handler and extract this context from the claims. So we'll say ctx And the context is just like information that the application has access to. So we'll say context, and we need to import this. So there we go. Dot with value r dot context, and we will set the context name to claims, and we will set its value to whatever the value of the claims is, which should be the username, the Zeta ID, and the rest of the JWT information. And then, oh wait, I already have that. So we'll say next serve HTTP, but we'll say the request body with context because we need to pass the context along, and we named the context CTX. So there we go. So now we have our JSON Web Token middleware. So before we jump into the CRUD for the projects, we're gonna first need to set up our JSON schemas. So I already pasted them in here, but basically we have two of them. We have the user schema, and this is just a way to validate the incoming JSON without having to write like individual validation rules and responses for every single different field. This is just a streamlined way. So we are going to be using the Go JSON schema package to provide the validation, the JSON schema validation for our JSON input. So go ahead and copy this over and copy in the project schema as well. So I'll probably, so go ahead and copy these in. I'll see if I can get these like posted somewhere so that you can copy and paste them. But yeah, so once you get these copied over, be careful of the regex. You might not honestly need this, but I put it in here because I wanted folks to be able to have like when you type your dev dependencies, if you have like a type like this, like at types / React, for example, that this would be considered a valid string. So yeah, once you get that in, then we can head back into our main.go. And well, actually, before we start with actually like working on these individual handlers, we want to use the JSON schemas that we just added, specifically the user one. We're going to add a middleware that is going to take care of the validation prior to the request body making it to the actual handler. So to do that, we're going to come down underneath the JWT middleware, and actually we will, so we'll go ahead and create a new function called validate. What the heck just happened? Sorry, that was weird. Validate middleware. And this will take in a schema as a string. Okay, string like that. And it'll return a handler function. Well, it'll return a handler function that also takes in a handler function, because this is a dude, what am I doing? This is a middleware that takes in a parameter. So where before we had middleware that just takes in a handler and returns a handler, like the JWT middleware or the logging middleware. In this case, we have a middleware that takes in a parameter and then takes in the other middleware. So it's going to take in a handler. It's going to return a function that takes in a handler that also returns a handler. That is a mouthful, I'm aware, but it'll make sense if you don't think about it or if you think about it too much, one or the other. So this is going to return a function, and the function is going to take in the next function because this is middleware. And why am I writing hijacker? Oh, that's cool. I didn't even know that existed. So HTTP handler, and it's going to return HTTP handler. And if this doesn't make any sense, like eventually it will, like if you do it enough times, but this is going to be the most complicated middleware that we're going to write. Frankly, it's probably going to be the most complicated function we're going to write. So this is also going to return the next HTTP handler. So we'll say return HTTP dot handler func, and this is going to take in as an argument the function. And I do not want to type this all over again, so I'm just going to copy. Well, maybe not that one. Yeah, I'm going to copy this, and this is going to handle the. Oh, wait a minute. Oh, pasted it into the wrong place. Like that. There we go. So it's going to take in a function like request, response, whatever. And in here, in this function body, we're going to first we're going to first define the body as a map with string keys and any type of value. So interface is 0. So this is short. This is the Go equivalent of a JavaScript object, where you have your keys defined as strings and you have your values as literally anything. So that's that. And then we want to read the body as bytes. So we'll say body bytes, air, body bytes sounds like a zombie apocalypse, io.read all. So we're going to read the body into bytes. And then we're going to do some error handling. So let's just grab one of these. Nope, not that one. Maybe one of these. Yeah, there you go. All right. So we're going to say, in this case, it's going to be if error does not equal nil. I need to stop adding so many spaces. There we go. If error does not equal nil, then we're going to respond with error. This is going to be a status bad request. Okay. And we're going to say invalid request payload. And this just means if the JSON is malformed, then don't do anything with it. I think I missed a parenthesis somewhere. So we have handler, handle func, w, all this. I added an extra one over here when I shouldn't have. Yeah, this was supposed to close. It was supposed to close after this yellow one right here. There we go. Cool. So, awesome. Now, I think does this have to have a comma next to it maybe? No, I think it's supposed to be like that. There we go. And this is screaming why? Unknown word. It's because I, as usual, spelled handler wrong. Handler func. There we go. All right. So now that we've actually checked the body if it's valid, the next thing we're going to do is we're going to unmarshal the JSON into the body variable. So it's going to look like this. Error equals JSON.unmarshal. Okay. And we're going to pass in the body bytes. And we're going to fill so whatever the unmarshaling step does, the result is going to be stored in the body variable that we created over here. And why is this giving me an error? Is this supposed to be caps? It is supposed to be caps. Okay. Wait, why? Oh, I didn't import IO. Why is it still? There we go. Sorry, my computer's really slow. Okay, so let's see if there's an error. So I'm just going to copy this again. And this time, if we have an error, we're going to do another status bad request, and we're going to say invalid request payload, even though technically the error is actually, I wonder. I think this should be actually a internal server error. Status internal server error, because this is technically an unmarshaling error, right? And that, well, actually, no. That I think bad request is right, because I think if it has an unmarshaling issue, it would be because of the format of the JSON. We'll put a pin in this one. But yeah, so next thing we're going to want to do is we're going to want to actually grab the schemas. We're going to want to extract it into a string. So we'll say schema loader, and this is going to be, actually, we need to import a package. And the package that we're going to be importing is Go JSON schema. I think I mentioned that already, but we're going to come in here and we're going to say go get github.com/xeipuuv/go JSON schema. Okay. And that's been added. So now I can actually come down here and we'll say go JSON schema dot new string loader, and we'll pass in the schema that comes into this function, because we're passing in, I don't know what I think I said earlier, something different. I think I said convert into a string, but we're bringing in the schema as a string. So we're loading the schema as a string to the, so then we want to actually load the document. So the document is the thing that we're validating. So we'll say document validator. So schema is the thing that's performing the validation, schema loader, and the document loader is the thing that's being validated by the JSON schema. So we'll say go JSON schema, and here we will use the new go loader, and we'll pass in the body because this takes in the body as a go in the go format, which in this case would be the go version of an object. All right. And if we were passing in the body as a string, then we would use the new string loader, right? And then we will actually validate. So we'll say result, error, and we'll set that to go JSON schema.validate, and we'll pass in the schema loader for the schema, and we'll pass in the document loader for the content that's being validated, or the document. So then we want to actually do some error handling just in case the error is populated. And I'm going to remove these extra spaces like that. And here we'll say that if there is an error, we will actually use the a internal server error, because if there's an issue with this error is not the result of the validation. This error is an issue with the validation logic itself. So this would be a server error. So we'll say error validating JSON. I'll probably do some caps like that. And if there isn't an error, then we actually need to check if the content was valid. So we'll say if result dot valid. Actually, it's if the result is not valid. So this is called a guard clause, right? We're checking if something's false before we move on. So instead of saying if valid, we want to check if it's false. So if it's false, we want to fail, right? So we'll say, actually, I don't know if this counts as a guard clause. Maybe it does, maybe it doesn't, who knows. Errors, and we'll set this as a slice of strings, string, and that, okay, I don't know what all that was, sorry. And then down here, we will add a for loop. So this for loop, we're not actually gonna do anything with the value that we're iterating over. We're just iterating over each thing, right? So we'll say, we're just iterating over it without actually using it. That's what this means. So for each element in the slice of arrays, or for each error, and we do range result dot errors to get the errors as an array. For each one of those, I probably have to open this. We'll say errors equals append errors error dot string, and dot string is supposed to be capitalized like that. So we're going to stringify the error, and we're going to append it to the errors array, or the error slice, and then we're going to respond with error and return. I'll just paste that there. And for this one, it's going to be status bad request, that one. And here, instead of error validating JSON, we're actually going to create a string. We're going to say strings.join. So this is going to be a string concat operation. And we're going to pass in the errors, and we're going to delimit them with a comma and a space. And that's supposed to be errors with an S, like that. So this is if we actually have JSON schema errors. This is how we're going to surface them, or return them, I should say. And then, if there's no errors, we will basically restore the request body and pass it on to the next request. So we'll say request body equals IO, dude, what is going on with me today? IO.NOP closer. Okay. And here we're going to say bytes dot new buffer. So we're going to read the bytes back into, we're going to read the body bytes. And then we're going to say next dot serve HTTP, and we will pass in, dude, why do I keep adding parentheses? We'll pass in W and R for the writer and the reader. Why did I write body? It's body bytes. There we go. Cool. And that's basically our validation middleware. Hopefully I got all that right the first time. So now let's actually use it. So we need to, well, we have to add another function first. So the function that we're going to add in order to use this, we just need to add a function for us to that'll allow us to load the schema from the local I don't want to paste the schema as a string here. I want to load it from the file system. So we'll say func load schema, And this is going to take in a file path. We'll do file path like that. And we'll make this a type string. And then it'll return a string and an error. And this is going to read the data or an error, like so. And we'll say os.read file from the file path. And this is because we have multiple schemas. So this will allow us to pass in the file path for the schemas and load them that way so that we don't have to like write this multiple times because, well, this sucks to write. So we'll say if the error is not nil, or if there's an error, then we're just going to return an empty string, what the heck, an empty string and the error. Sorry, the microphone is like in the way of me, like my keyboard's on my lap and the microphone's in the way. So like I tend to like, I'm trying like not to hit my headphone cable when I'm typing. It's a little annoying. So we're going to return string data, so the data from the actual file, and nil if there is no error. Cool. So that's our load schema. So I'll just say, we'll add some Godoc here. We'll say load schema loads a JSON schema from a file. There we go. Now we got some Godoc. So now let's go ahead and add our validation middleware to our auth routes. So up underneath here, right, like underneath the environment variable loading, we'll go ahead and define a load error as an error because this is a different kind of error. So we'll say, oh, dude, what is going on? Come on now. And we'll say user schema load error, and we'll set this equal to load schema, and we'll pass in the file path, which would be schemas/user.json. And if you have issues here, just check where you put the actual schemas folder, and you should be good. Okay, so if there is no load error, or sorry, if there is a load error, so if load error is nil, it's really hard to read this like front to back, sorry. Then we will log fatal F error loading user schema, and this is going to take in a value, and that value will be the actual loading error. Now, if there isn't an issue, then we actually need to use the user schema down in, we'll put it in front of the register route. So we'll say we're going to create a Alice chain. So we'll say user chain. And you can technically just say chain and like redefine it for each one that's different. But in this case, I want to be verbose just to like be like explicit about which one is which and make it easier to follow. So we'll say alice.new, and we'll pass in the logging middleware as we were doing before. And we'll pass in the validate middleware, and we'll pass in the user schema. And then we can take this user chain, copy that. And then for the login and for the register, for these two, we'll just Control D to select both, paste the user chain. And now we actually have the middleware for the validation set for the register and the login route. So here I'll just add a middleware chain and routes for user auth. Cool. So let's go ahead and test this in Postman somewhere. Where's my Postman? There it is. So if I come over here and I spell username wrong, hit enter, this right here, this message, user is required or username is required, additional property username is not allowed. This is a JSON schema error. If I type it correctly, and remember I said that there's a minimum of 4 characters. So if I put 3 characters here, I don't know why I use 3, but we'll use it. It'll say string length must be greater than or equal to 4. So if we put 4 or 5 like that, now, oh, this was user registration. So, okay, that's fine. So it actually registered the user, all right? But then if I try to do it with nothing, it'll say it must be length 4, and you get the idea. So yeah, so that's our JSON schema validation, and this will be the same validation that we actually use for the projects route. So now let's go ahead and start cranking out these project routes. So first things first, let us go up here where we were defining our user schema, and we're just gonna hold Alt Shift down, or not hold it, just like press those three together once, and we're gonna rename this to, well, I'm gonna highlight user, I'm gonna hit Control D twice, and I'm gonna change this to project, and now we can load our project schema. And don't worry about the load error being reused, because what this means is first it'll load this, and then if there's no errors, then the error will be stored, or this value gets like written at the next stage. So now we'll take this project schema and let's head down to the routes. And what we're going to do is before before these two, we will put the, we'll create a middleware chain for projects. So we'll say middleware chain and routes to for project creation and modification. And for this one, we'll just we'll grab this user chain, paste that there, and we'll change this to project chain. And here we will say project schema. And we're also going to add our JWT middleware. So we'll say app.jwt middleware, because remember, we added this in here so that we could have JSON Web Token authorization prior to actually running our request. So we want to validate, we want to get our like user information out first, make sure the request is authorized, then we'll validate the request body, and then we'll use that project chain in front of this one's actually only because the gets and the deletes don't take in a body. This is only going to be used in front of the put and the post, right? So these are going to not use those, but the create project and the update project will. And while we're here, I'm just going to redefine create project as a method of the app struct, because we're going to need access to the whatchamacallit. Man, I'm tripping right now. The Postgres instance, sorry, the database. So let's go ahead and head down to create project, and I'll just copy this from the login, paste that there. So now create project is a method of the app struct, or the app object. So now let's go ahead and start making this thing happen. So first thing we're going to want to do, we're going to define, oh, actually, hold up, there is something I forgot. So remember how when we create a user, we have our user, we have our credential struct. We also need to have a project struct. So let's say, yeah, right here is fine. So go ahead and copy this down. These are the fields that go with the project struct. Everything is like similar to what you've already seen. The only thing that's different, excuse me, is that the dependencies and dev dependencies are string slices, not individual strings. Just make sure you get your annotations right. Do remember the double quotes inside of this. And once you get this written down, let's head back to our create project. And in here, we're going to define our project. This is the request body, or the object that we're going to store our the response that we send back with. And what we're going to do is first, we're going to decode the JSON from the request body. Dude, where is my colon? Oh my God. JSON.new decoder. And we'll pass in the request body. All right. And we will decode this into the project struct. Like, well, it was lowercase. There we go. So if there's an error, we will handle it. We will respond with a status bad request, or error 400, and we'll respond with the message of invalid request payload. Now, if there's no error, we're going to need to get the user ID from the claim. So we're going to need to figure out who owns this project, and we're going to do that by extracting the user ID and the user Zeta ID from the claims, which we stored in the context in the JSON web token middleware. Rewind and rewatch that if you're not sure what I'm talking about. So we'll say claims, and we'll set this to r.context. So remember, we stored the information in the context, and we will get the value. We'll say, oh my God, we'll say the value is the string that we defined as claims. And we will pass in the claims struct Lord Almighty. There we go. Okay. So what this means is that we're going to get the claims from the request context, and we're going to extract out the user ID from them. So to do that, we'll say user ID, and that comes from claims.zeta ID. Okay. Now, we want to first, before we start writing our SQL query, we want to, I don't know what that sound was. We want to define a value where we're going to store the project Zeta ID. So we'll just say var Zeta ID string, and then we will write our query. Now, I am just going to paste the query in here, and I'll explain what it is real quick. So you've already seen the appdb.query row. In this case, we're going to be inserting, into the projects table. And what we're going to be inserting is the user, which is going to be the user ID or the user claims Zeta ID. So this is the actual ID reference, not the username. We're going to pass in the project name that we get from the request body, the repo URL, which we would get from the request body, and basically everything that has a project dot comes from the request body. The one thing that we need to do real quick is if you see here, it says undefined PQ. So we need to import the Postgres package. Now you'll probably be saying, wait, I thought we already imported it. You are correct. However, we imported it anonymously. So now, because we now are importing it explicitly, we can come over here and we can get rid of this line because we no longer need that duplicate import. So we can come down back to our query, and you'll see that once this, so these 8 values get plugged in from these 1, 2, 3, 4, 5, 6, 7, 8, these 8 values. And then we're going to return the Zeta ID as confirmation. And we're going to scan that into the Zeta ID variable that we defined right above. If there's any errors, we want to return an error, internal server error, and say that there was an error, an issue with creating the project. If there aren't any errors, we want to set the project ID and the user ID. All right. So remember, the Zeta ID, we get it back from the request, and the user ID, we got it out of the claims. And once we get those, we can respond with a content type of application.json. And over here, we're just going to encode this with the project object. So we come to our Postman, we open our collections, and we go to projects, and we'll say create a project in our body. Let's see, let me just minimize this. So we have my first project, a bunch of other stuff. Hit Control Enter to send it, and you'll see there's a bad request, invalid token, because it's been a pretty long time since I recorded. So my token's expired. So we'll go ahead and log in again. So we sent our login, we got our token, we go to create a project, we send it, and because my token is now valid, we get a response, the Zeta ID from the database, the user who created it, all that kind of stuff. So now if we head to Zeta, see what that looks like. So here we are. You'll see there's our new users. We'll go to projects, and there's our new project. So React DOM, there's no description. There's a name, my first project, yada, yada, yada. So there you go. So before we move on to the put request or updating a project, I do want to make sure that we can inspect like what we are creating, and just make sure that the user who's logged in can't see the like any other users' projects. So what we want to do in that case is actually move these requests down underneath the delete. And the reason we want to do that is because we're gonna we're actually going to reuse this project chain. So right over here, actually, let's cut that, paste that there. And right on top of the get projects method, let's go ahead and define, or we'll copy this and paste this here. And instead of passing in the validate middleware, we'll remove this. That way the project chain runs before all of these. So we'll highlight alice.new login middleware for these 3 requests, and we'll paste the project chain over here. Now, what we need to do to actually get the validation working for the what's the word I'm looking for? The post and put request, the create and update, sorry. Well, first let's do this. Let's say middleware chain and routes for project reading, for getting all projects, deleting a project, or for, let's say this, for all project requests that do not require a body, a request body, and then middleware chain and routes for project creation, deletion, for, let's say, for project routes that require a request body. And the reason I'm saying this is because we want to, anything that requires a request body, what we're going to do, we're actually going to say project chain with validation. And instead of saying alice.new, what we'll say is project chain, like that. And then we'll say append. And we're going to append the validation middleware, like so. Okay? And the idea here is the project chain gets surfaced as an array, or a chain, one thing that happens after the other, right? So in this case, the first thing that happens in the middleware is the logging middleware, then the app JWT middleware. We always want this to appear in front of any of the authorized routes, because this is the thing that basically kicks a person out or refuses the request if they are not authorized to do anything subsequently, right? But then over here, we're still using this logic, but we just want to add the JSON schema validation as the last middleware in the chain, and then run the middleware. So I don't know if that made any sense. So I do need to copy this and then replace project chain with that. Now the thing is, I don't actually have to do that. I can do this. I can basically redefine project chain and then just do this. But this can be a little confusing, and it's not as like straightforward. So I'll leave it like this. And if you want to do it the other way and you just want to redefine it, it doesn't matter because these won't be affected since it runs since the code runs sequentially. So it's all up to preference, right? For me, I just want to make sure that it's like clear and understandable. So now that we kind of have that, let's go ahead and implement get projects before we move on to the next ones. So for get projects, we want to make this a method of the abstract. Now this one's going to be pretty straightforward. So we're just going to head down to get projects, and we'll say for the Go doc for this one, we'll say get projects, I don't know, handles getting all of a specific user's projects. Yeah, that's fine. So inside of get projects, we want to first get the claims from the context, like so. And then we want to get the user ID out of the claims, like so. Okay, and you probably recognize this from the create project route. Now what we want to do is we want to create we want to define rows and error, and we're going to query. So we're going to do app.db. Oh wait, we need access to the app. So we'll say app is of type Dude, I can never get these right. There we go. App, star app, cool. And we'll query. In this query, we'll say select. We're going to basically be selecting everything. So we'll say select Zeta ID. I'll just paste this query in here and you can copy it. It's pretty straightforward. So it's going to look like this. There we go. So we're going to be grabbing the Zeta ID. We're going to grab the user, which this is going to return the user ID. We're going to grab the name, the repo URL, basically everything from the project where the user is equal to placeholder. And this placeholder is going to be the user ID that we extracted from the claims object. So basically, this means we're going to grab all of these items as long as the user that's defined in that row is the same user that's making the request, right? So it's kind of like a filtering mechanism. Now we'll say, where's my error handling? I'm just going to grab one of these. So we'll check if there's an error first. So we'll say, if there is no error, then we're going to say status internal server error. Yeah, that's right. And error fetching projects. Cool. And then we'll return. And then we will defer the rows.close. And that's just deferring that's just making sure that we close the reading operation at the end of this function's execution. All right, so let's go ahead and define a project slice. So this is going to be the array of projects that we end up returning in the request. So we're going to want to iterate over the rows that we get back in the response. So for the rows, we want to define we want to, I guess, first declare the project variable. And we also want to define the array of strings or the slice of strings for the dependencies and dev dependencies. Then we're going to scan the row into these values. So project Zeta ID, project user ID, yada, 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 yada. And then when we get to the dependencies, we're going to use the Postgres array function to basically expand the dependencies into the JavaScript array that they are, or the JSON array, excuse me, that they're going to be stored in the response. So then we'll return a error if there's an error. So we'll say, yeah, that looks good. So we'll say that the error, internal server error, and we'll say error scanning project. All right. So remember, this is for each project in the row, right? So it's going to be doing this iteratively for all the projects. Now, of course, if you have a million projects, this is going to take forever. But we're not focusing on like scalability in this tutorial. So next thing we want to do is we want to say project.dependencies equals the dependencies. Because remember, we first define these as individual variables because we need to first scan them in. It's a little bit like, it's not as, actually, I wonder, I'm not actually sure if I can just come in here and say project.dependencies. I haven't tried this method. Honestly, I probably could, but I'm gonna play it safe and do what worked. I'm sure there's a reason why I did this, but so project dev dependencies equals to project dev dependencies. There we go. And then we're going to append the projects. So we'll say projects equals append projects project. So we're going to append the project that we just iterated to the projects that we defined before we entered the for loop. All right, so we'll go ahead and close that for loop. And at the end of this, we're going to check if there's any errors that we encountered during the process of querying the rows. So we'll say error equals rows.error. Cool. And if there are errors, I'm just going to grab this. So if there are errors, then we'll respond with an internal server error, and we'll say error fetching projects. Cool. Lastly, we decode, or we set our content type to application JSON, and we will just encode the projects for the response. Save that, and let's give it a try. So let's head to Postman, and we'll go to our collections, and we will grab get all projects. Hit Control Enter, And there we go. So we have one project. We're going to create another one just for testing purposes. So there we go. Hit Control Enter again. And we have two projects in here now. So let's try logging in as a different user. So I think I have another user called my second user. Hit Control Enter. So now I'm logged in as my second user. So if I hit Control, if I get all the projects now, I'm going to get nothing because that user doesn't actually have any projects, right? So if I come in here and I create some, so there we go, we created one, Control Enter, and now he has one, or they have one. I'm a dude. I'm gonna call him a he. He has one project. So yeah, there we go. So that's basically, yeah. So that's our authorization at work. Now, if I were to remove the middleware, so let's say, where was it? Yeah, over here. So let's say that I removed the JSON Web Token middleware from over here. Well, actually, this will break everything because if I remove this, then I won't even get the user ID. So it'll kind of fail, I'm pretty sure. So we'll give it a try anyways, just for funsies. So now, oh, it's restarting the server. Interesting. Oh, yeah. Yeah, it's totally busted. Yep. So that doesn't work because we are requiring that the claims exist in the. We're requiring that the claims exist in the context when we actually get to this function. So now let's go ahead and implement the get project route. So first and foremost, we'll go ahead and add the app dot in front of this so that we can make this a method of the abstract. And we'll head down to get project. Oh, wrong one. To get project, let's go ahead and add, or I'm going to hit Control K, Control 0 just to minimize everything because it's getting a little out of hand. So we'll just grab this and paste that there. Cool. And now, oh, there is one thing we need to do. So let's head back up to, bro, where is it? Dude, what's going on? Okay, there we go. So let's change this right here so that instead of saying ID, we're using Zeta ID. And I'm just doing that so that I can stay consistent because that is what we're going to be using in the URL parameters. So now let's head back to get project, and we'll say instead of this, we're actually getting the Zeta ID. So we'll just replace this with Zeta ID like that. Cool. So like we did before, we're going to get the claims out of the context and we're going to extract the user ID out of it. So there we go. And now we're going to, because this is one project, we're only going to define a single project object with the type of the project struct. We're also going to define the dependencies and the dev dependencies as arrays of strings. And then we're going to query the database like so. All right, so we're going to grab the Zeta ID, the user, and the name, basically all the fields, and we're going to pass in the Zeta ID and the user ID. So the way this works is before where we were saying where and then user, now we are specifying specifically what project we want to get back. So in this case, we want to get back the project where the Zeta ID is equal to the Zeta ID that we extracted from the URL parameters, and the user ID is equal to the user ID that we extracted out of the JSON Web Token. Okay. So we'll close this brace and then we'll scan the values into the appropriate project values, and we'll do the same thing that we did earlier with the dependencies and dev dependencies, and then underneath here we'll do some error handling. So let's just grab the error handling that we had in get projects. So we'll say, I'll just grab one of these. All right. So under here, we will first check if there's an error querying the project. So you'll remember when we did the login, how the first thing we had to do was check if the user existed or not. So in here, we're going to say if error equals SQL.error no rows, right? So if the thing was not found in the table, then we'll return a status not found, and you probably recognize this one. So here we'll say project not found, okay? Then return. Otherwise, it's going to be an internal server error, and we'll say error fetching project singular, right? Next thing we want to do is we want to go ahead and set the project dependencies to the dependencies that we use the PQArray method against. So we'll say equals dependencies, and same thing goes for the dev dependencies. Dev dependencies. Cool. We have our header, and then we'll just replace this route response with the project. Cool. So let's go ahead and test this. Head to Postman, and this time we will get project by ID, and I have a random ID in here. It's not going to work because this ID doesn't exist. So let's go ahead, run get all projects, grab one of these, and paste that there. Oh, there. That's wrong. There we go. So now we actually get the project. Now, if I go ahead and log in as a different user, so we'll say we'll log back in as my first user, and I'll try to get this project by the ID. This one was my second user's project, but if I hit enter, because I'm not logged in, it just returns with project not found, because I don't want to tell the wrong user that you don't have access to this project, because basically I don't want to like security by obscurity. That's that's the idea. Now we can go ahead and get into updating our project. So let's head back to our main function, and above our main, all I have to do over here is just add app dot to make this a method of the abstract, and we will head down there. I am going to copy this and paste that like so that we can get that error off of our chest. Cool. Oh, and then I do actually need to make sure that that it's the Zeta ID that we're passing in over here and not an ID. Cool. So let's head back down here. All right. And we are extracting the Zeta ID like that. And it's going to be like that. Cool. So before we actually do this, let's first run through some of the logic that we need to actually run prior. So we need to first check that the body is in the correct format. So I'm going to grab basically everything here from the create project. Okay. And we're going to paste that above this, right? Because first we want to make sure that the body is even like valid, right? So we'll say, yeah, that looks right. And then before we extract the user ID from the claims, then we'll check for the Zeta ID like that. And then we can actually grab the user ID from the claims. Cool. So the first thing we want to do is we want to check if the user is even allowed to access this record. So we'll say we're going to define the stored user ID, and we're going to query the database or the table, excuse me. We're going to query the user, the user ID from the projects table where the Zeta ID equals 1, right? So we're going to pass in the Zeta ID, and we're going to grab the user. And then we want to actually check if something returned, right? Now, the reason we're doing it this way and not by just like inserting where the user and the ID exists is because we first want to check whether or not the project actually exists first. Because otherwise this, for some reason, this actually passes. Even though it doesn't create a new record, it's a little bit confusing. But what I encountered when I would do this, where we would just run the update command, is it would basically do a false update. Like it would tell you like code 200, yes, successfully happened, even though the record that you passed in didn't exist. So this, at the very least, first checks whether or not the thing even exists, and if it does, it returns the user ID to you. And we can then use that to verify whether the user is even allowed to modify the specific record. So the way we're going to do this error handling is we're going to check first whether or not the SQL query returned with any errors. If it didn't, then project is not found. Otherwise, the error would most likely be an internal server error. So we'll just return an internal server error. So after that, assuming that this query succeeded, we then need to check if the user ID that is in the database matches up with the user ID of whoever is making this request. If it's not, then we fail with an error 403 because they are not allowed to actually modify this project. Right? Now we could say project not found, and I think that's the better way to do it. But at the very least, this kind of like just, acts as extra, a little bit of extra validation, right? Plus, if you want to like update this so that you want to have projects be readable but not writable by the person who's not the owner, then this is a way that you can implement that. So the next thing we want to do is we actually want to run the update query. So we'll say, so we'll execute an update. So then we'll execute an update query where we'll pass it. Now, I know this syntax looks a little weird. It's a little bit different from the syntax before. It's SQL. So we have to pass in the name, the repo, the site ID, right? So we're passing in the site URL. We're passing in all the values from the request because this is a put request. So the way a put request works compared to a patch request is a put will overwrite the entire thing, whereas a patch will update individual pieces. I found it a little bit easier to deal with the put for this project, but if you want to use the patch, that's also an option. But yeah, so once you get that done, then we'll return an error if there's an issue. So we'll say server internal error if this fails. Otherwise, we'll just set the Zeta ID and the user ID of the project to what we extracted from the URL parameters and from the claims. And then in our response, we will just return the project like so. So this is now the updated project. So we'll save that and we'll head back to Postman and we'll give it a test. So if we go to, I think, was this one not found? This is not found. So let's just log back in as my second user like so. And then we will, we'll get this project. Cool. So now let's head to update project by ID. I'm just going to grab that ID again. And here we're going to say, in the body, we'll say my first project, my first update to my project. So we'll change the name. And for our dependencies, let's add, zoo stand. And we'll also add, for lack of foresight, Lodash. And then down here, we'll just add type / Lodash. Oh my God, I cannot spell. By the way, if you're wondering, status in the way we define it in JSON schema can only be either backlog, developing, or done. So if we put in potato and we hit enter, it'll say that it needs to be one of the three. So we'll just move this to done and we'll hit enter. There we go. So now if I hit back to get project by ID, and if I get this again, you'll see I have the update, my first update to my project, zoo stand, Lodash, types Lodash, status done. Cool. And I think at long last, we're at our last request, which is the delete request. So this one should be fairly simple. We'll just head back to our main.go or our main function, and we will update the delete project to be a method of the app, and we'll head down here. Oh, geez. We'll head down here. We'll add this to the front, save that. And then inside of the delete project, we need to update our route variables to Zeta ID, and we need to extract the user ID from the claims object. Now, I don't believe I updated delete project to use Zeta ID, so let me just copy this and head over to where it is, and there you go. Let's update that. Head back down to delete project. Cool. So next thing we're going to want to do is we're going to want to grab the stored user. And what we're going to do before we delete something is we want to make sure that the user is actually allowed to delete it. So we're going to query the database first. So we'll say that we're going to grab the user from the projects where Zeta ID is equal to the ID that's passed in. And like we did with the update project, we're first going to report on whether or not there are any rows returned. If there are no rows found, then that means that the project does not exist, so it was not found. And otherwise, there was just an error with fetching the project, and it's most likely an internal server error. After that, we're going to actually do some authorization. So we'll check if the ID that's in the database, so because the select user fills out this stored user ID variable, we can then compare it to the user ID that's in the claim. So the user ID that's in the database gets compared to the user ID that's in the claim. If they don't exist, then you do not have permission to delete this project. If that's not the case, then we will delete the projects where the Zeta ID is equal to 1 and the user is equal to 2. And I know this is a little bit overkill because we already verified the user is not the person who's allowed to do it, but it doesn't hurt to be a little thorough. So if there's an issue with this, then we'll return an internal status error with the message error deleting project. And then lastly, because this doesn't actually have any response, we will just get rid of this last JSON bit. We don't need the content type of application JSON. Instead, we will just write a status header of status no content, meaning the delete has succeeded and there is nothing to return. So we'll save that, and then let's go ahead and try it out. So we head to Postman, we go to update project, we grab the ID from here because we know this one exists, and we head to our collections, go to the delete. First, we're going to try a project that does not exist, project not found. Then I'm going to log in as a user who does not have access, so my first user. And just to verify that, I'm going to try to get that project not found, cool. And then I'll paste this ID in here, and it says you do not have permission to delete this project. Let's go ahead and log back in to my first, I have too many users. My first user, but wait, was it my first or my second? I think it was my second. So I know I mentioned earlier about security by obscurity, but this is just so that you can see like what I was talking about, because you can kind of track this down to this particular error where it does the comparison. And you can change this back to something that is a little bit more obscure. I control enter, and what? Are you sure about that? Hold up. Oh, wait, did I try to register the user again? I tried to register the user again, my bad. Okay, let's verify that we can get it. Okay, we can get it. So now let's try to delete it. Status 204, no content. We head back to get project, and it says project not found because the project was deleted. And that's, I'm pretty sure that's all our, that's all our routes. So there is one thing that I wanted to do real quick, just for the sake of like cleanup. Let's head back up to this behemoth, right? And I'm just going to zoom out a little bit. And what we're going to do is we're going to move all of the routes to their own function. We're going to call it func setup routes. And in here, we're going to pass in the router. This is going to be of type wherever the hell it is. There we go. mux.router app star app user schema and project schema of type string. Cool. And then inside the function body, we're going to copy everything from this line up till here. We're going to cut that. We're going to paste it into setup routes. And then right underneath this line, where we have the log print line, we'll say setup routes, and we'll pass in the router, the app, the user schema, and the project schema. And now everything is nice, compartmentalized, and it's still in main.go. So I can go ahead and restructure this. Should I do that though? It'll take me a little while, and I think this video is long enough. But the way I would restructure this myself is if I were to create a new directory, I would say command. So this is where you would put your entry point. So we'll say inside of the command, we'll have the API, and then inside of the API, we'll have our main.go. And this is where the main entry point logic would go. Then I would add a new folder like this, internal, and inside of internal, I'll have internal basically means that it's like private. It can't be accessed by other packages. So in here, we'll say API. So this is where I'd put, like, for example, handlers.go, and I'd put routes.go, and I'd put models.go, and I'd put middleware.go, and so forth and so on. And the idea is you can split up your app so that it's a little bit cleaner. But in our case, the main purpose of this tutorial was just to kind of give a brief introduction. It's like 3 hours and a half long, I think, right now. A brief introduction to Go and building a REST API. So it's a little bit more like functional and practical than a typical like syntax-based tutorial. In this case, you actually built something useful. And, Go is not super opinionated about how to structure your repository. So you can actually structure it however you want. In this case, we did it the worst way and the most lazy way possible, which is in one main.go file. But I mean, I'm doing this for free, so you can't expect quality out of fast food. So that's I think that's it for this tutorial. This is my first crack at doing like backend. I know it's like probably not as smooth as front end, but yeah, if you like this, do the thing. And as always, I hope you guys learned something today.